Hey everyone, welcome back. Previous video we have discussed about this about the normalization. So before we have learned this attribute and function and dependencies. So based on that we are going to learn this normalization. So today we'll completely discuss about this normalization. So first let me keep the definition over here. So what exactly the meaning of this normalization, because it's a very important thing for the developing team. It's one of the design techniques. When we are doing the SDLC, we especially use the normalization when doing the designing stage. In this designing stage, architecture will design this entire normalization part. So first, let me give the definition of this. So what is normalization? Means it's reducing a table to its normal form. Normal form is known as reducing the table to its normal form is known as normalization, which means whenever we have a big table, we have to convert into the smaller table. That means is that the definition. So else we can go with another easiest definition. One more definition we have, that is it is one of the process. This is a process of decomposing a larger table to the smaller table, larger table into a smaller table is known as normalization. So we can use any definition, doesn't matter about the definition. So I hope everybody can easily understand this first definition, reducing the table to its normal form. So these two are very simple definition. We can go through one. So now I'm give small example to understand this. I'll just take it as one table. Just assumption it is one of the table. I would say this is a complete table. In this table all the information are present. So this table, it will be converting into the small table. So based on the in this big table all the information are present, that it will be converting into the smaller table according to the customer requirement. And we cannot store some clumsy data over here, and whenever we have a clumsy data we cannot identify what exactly the data. So that's why we actually do the normalization. So like this it will be converting into the different tables. According to the F code, we can store the data in multiple table. If necessary, we'll just give the connection or relationship between the tables. So this is how we achieving the normalization. So without doing this normalization, we cannot create a table, or we cannot develop any project. So it is I would give this my normal form table 1, and I would say this is my table 2, this is normal form table 2, and the last one is normal form table 3. So likewise we can use different tables. So this is how we achieve the normalization. But we have one more confusion over here. What is that confusion? So this is a normal form, I told you. So reducing the table its a normal form. So what exactly the normal form? See, in each and every normalization, we have a normal forms. Each and every step will be doing this normal form. So actually we have a 6 normal forms over here. So before that, we'll understand what exactly the meaning of this normalization. So I would say the a table without a table. Oh my god. Table without redundancies. Table without redundancies and anomalies are said to be a normal form. So what exactly the meaning of this redundancy? Redundancy mean it is a duplicated values is called as redundancies. Okay, let me type it. This redundancies and anomalies are said to be normalization. So it's a normal form. Okay, so let me talk about this redundancies, because this word in industry so many people are using this word, so we have to know about the meaning of this redundancies. So what exactly the meaning of this redundancy? It's actually unwanted duplicate values. You can say some unwanted wanted duplicate values or repeated values is known as redundancy. We should know about this. Next, one more point is there, that is anomaly. This is the side effect caused by the DML operation. So most of the time we are facing some side effects from the anomaly. The side effect actually caused by the DML operation. DML operations such as insertion, deletion, updation. So actually we are facing some basic problems or effects. So that's why it is called as anomalies. Okay, so now we'll talk about this. How many levels are present? Levels are in normal form. So total we have a 6 normal form. So let me type it one by one. First one, first normal form. First normal form, also known as 1NF. Second one is second normal form. Second normal form. Another name is also known as 2NF. The third one, third normal form. Third normal form, also known as 3NF. The fourth one is Boy's Code normal form. Boy's Code normal form. So it actually is also known as 3.5 NF and another name BCNF. BCNF. BCNF full form is Boy's Code normal form. Fifth one, that is fourth normal form. 4NF. The last one is fifth normal form, 5NF. So this is about the different levels which we available in the normal forms. So if we achieve the first 3 normal form, then the table is said to be a normalization. So that's why I'm going to give some important note over here. So what does note says? So pretty simple. If any entity or object or a table, any entity or object or whatever it may be, a table, if it is reduced to 3NF, then said to be normalized. In the table said to be okay, let me type it here. Then the table said to be normalized. So this is how we achieve the normalization in industry. So we can go with that. So first normal form, how the first normal form will be working. So let me take this first normal form. Okay, with the bracket, let me keep it as 1 enough. So now we'll talk about this, how exactly it will be working. So I need one example. So before that, so if you want to achieve this first normal form, so I have to follow this rules and regulation. It should follow, it should satisfy, or it should follow some basic rules and regulation satisfied below conditions. What are the conditions have to be achieved over here? The first one, so always the table should not have a duplicate values, which means we should not have a duplicate values, all are unique. Okay, so the table should have the unique values. Unique value should be have. Next, second one, what does second point say is its multi-value data should not be present. Multi-valued data should not be present. So also known as atomic values. Atomic values means it's a single value. The full meaning of this, single valued data. Single value data is known as atomic values. Okay, so when the below condition is satisfied, then it considered as a first normal form. Okay, so let me take one example table. So I'll just example. What are the example we have? I'm just take it as student is my table. In this student table, I have some information. I'll just take it as 4:4. student ID will be there, student name will be there, then age of the student, gender of the student is there. So this is our attributes. So based on the attributes, we should decide. So which one is the prime key attribute? What are the non-key attributes? Everything we have to decide it. Then we can use this. Okay, now I would consider SID is my prime key attribute. So before deciding this prime key attribute, I have to check what are the values are present in this table. Okay, so let me take DOM, SOM, DOM. Age of the DOM is 20, 21, and 20, and gender is okay. Instead of this gender, I'm going to take this phone number of the student. Phone number the student, just write it as 101, the person another 120, and 102, another person having the same phone number 101. Okay, so according to this, we have both here in this table. We have some duplicated value also, and along with the multi-valued data also. So first, we'll check it out, the duplicate values. So what are the duplicate values? See, row by row we have to check. So in the first row, it will be compared with the each and every row. When I compare with the second row, there is no duplication present in the second row. But when I compare with the third row, we got a duplicate value. So let me mark it, duplicate value. The different color. So this is my duplicate value. I would say this is my duplicate value. According to the rule, the duplicate value should not be present. If the duplicate value is there, we have to remove it, the duplicate value, because from 1 and 2 values are same. So that's why it is a duplicate value. And also, what we should have, we should not have this, we should not have this multi-value data. Okay, each and every table has atomic. Okay, in the cell I have a 2 value, means SOM having a 2 phone number, but according to the rules it should not be present. Duplicate value also should not be present, and multi-value data also should not be present. Okay, let me write, this is multi-valued data, that is also should not be present. So if the both is present, or if sometime multi-value data is not be present in the table, but duplicate will be obviously present. Okay, you have to make sure that, and you have to remove it, all those things. So this is my multi-value data, and the duplicate data is there. Yes, now I'm going to make it my table into the normal form. How I can do this? I'll just take it as the same table. This is my normalized table. Okay, I'll give this heading as normalized table. So first, I just deleting the duplicate value, so that's why I'll type only one time the data. His age is 20 and his phone number is 101, and the second person is 2 and his name is SOM, and his age is 21, but the person has a two phone number, 120 and 102. So if you are trying to store the data, means multiple data into the single cell, the first data will be erased and latest data will be updated. So that's why I need to keep data. So what I do is I just creating one more column, and I'll keep it the name as alternate phone number. Alternate phone number. In this alternate phone number, I can keep it my another number. So this empty cell is set to be null. Yes, this is how we achieve the first normal form. You can compare the older table with the normalized table. So here all the data are cleansy and more records are present. But when I do this first normal form, the things are very easy to identify and the data are easy to identify. So that's why we follow this normalization. So now I'm talking about this row number 2. I mean second normal form. Second normal form 2NF. 2NF. So how it will be working? Again, the same thing I am going to say. It should follow or satisfy the below conditions. What are the below conditions to be satisfied? So the first one, what I would say is the table should be in a first normal form. Okay, without doing the first normal form, we cannot go with the second normal form. It is already in the first normal form, then we can directly do the second normal form. But according to the rules and regulation, we have to do first normal form first. The table should be in first normal form. So this is my first condition to be satisfied. Okay. Then one more. Second condition is there. The table should not have the partial functional dependency. So this two condition to be satisfied. So how we can satisfy this? Okay. So let me take this one example. So here I'm going to select as my employee table. Okay, so most of the interviewer might asking you this employee table, so that's why I'm talking about this employee table. So let me create one simple table. Okay, so now I would write this employee ID, then employee name, then salary of the employee, then the department number of the employees and department name of the employee and location of the employee I'm going to select. So here we have some value. So what are the value we have? So employee ID, I'll just keep it as 1, 2, 3. I'll again write this same 1, and employee name Tom, Song, Pong. Again I'll write it as Dom. Salary 100, 200, 300. Now it's 400. I am just using, and here I'm just keep it 4 over here. So next, when it comes to this department number, 10 is there, 20 is 30, and again the department 10. Okay, the department name, I'll just give it as D1, D2, D3, again D1. Location L1, L2, L2, L3, again L1. So this is my table, uh, employee table. Here all the informations are present here. Okay, so when I check this, when I trying to do this normal form, first normal form, so I don't get any duplicate value. So according to this department, you can say this is the duplicate, but I would not say this is the duplicate, because the person name is same, and person salary is different, and person the same, same name have the person working in the different, I mean same department also. When the two people are working in the same department, obviously the department name and location all will be the same. But what happens is, so here when I check this only, okay, when I check this three columns, so now I can consider a few of the duplicates. So what I can do is I'll check with the partial functional dependency is there or not, because it's a big table, so I need to convert into the smaller table to identify the data easily. So that's why I want to check is there any partial functional dependencies is present here. Yes, we got a partial functional dependency through the composite key. So how to identify the composite key? So two or more non-prime key, two or more non-key attributes. So now I would select this department number, because all the department number are the different things, but different employees comes, obviously multiple department numbers are repeated. So that's why I would go with the table here, and I consider employee ID and the department number or my composite key. So this is my composite key. Composite key attributes. When the composite key attributes is present, so we consider as a partial functional dependency. Okay, so if you don't know about the partial functional dependency, you just go to the previous video and then first watch complete the previous video, then you can go to the normalization part 2 video. In the part 1 I have explained all those things, so just follow this, and also I'll give the link in description, you can go to that. So whenever we have a composite key, it is considered as a partial functional dependency. When the partial functional dependency is there, again we need to break the table. So now I decided to break the table like this. So I'll just break the table over here. Okay, so like this I am going to break my table. So this is one part and this is another part. So now I would write my reduction and just reduce the table. My first table reduction is, so what are the columns? I'm going to select employee ID. I'll make it as a main key because I consider as a composite before that. So e-name and salary is depending on my employee ID, and same also I'm going to do this reduce to second table also I'm going to reduce. How can I reduce this? I'm going with the word part. Here I'm going to select this department number. For the department number, D name and location will be dependent. So now we have to separate the table. How I can separate the table? So first I will take it as this employee table. So this is my employee table. Okay, so and I'll just give the name of this EMP, and for this I'll just give it as department. Why? Because all the department details are one side and all the employee details are in another side. Okay. Department. So now I'm going to do this reduce one, means first table I'm going to achieve it. So how can I do this? Just copy paste from this existing table. Just copy and I paste it over here. So here I'm going to check this, is there any duplicate values? Since I didn't get any duplicate value, so it already in the first normal form, and I would make it as this employee ID is my primary key or main key attribute. I can consider like this. Just change it as the color. Okay, so this is my primary key, and the similar manner I'm going to do the another reduction. What is my another reduction? To that is my department table. Okay, so in this department table, what I'm going to do is I'll just copy this all those things and I paste it over here. One minute. Okay. Yes, again I'll be creating one table over here. Yes, 3 columns. Okay, so now I'll keep it as this department number. I'll make it as my primary key, and the second column is department name. The third column is location. So now I'm checking is there any duplicate values present in the reduce to table. Yes, we have some duplicate values. If any duplicate values is there, if any repeated values is there, we'll just remove it and we'll start to storing the value. Okay, so the department 1 and department 2 and department 3, this is location 1, location 2, and this is location 3. For the fourth record have the same duplicate value. So what actually the F code told about this normalization. So if really necessary, we can establish the connection through the foreign key. Yes. So we can give the relationship of the two table. So what is my another thing is I'm just use it as my foreign key. I'm just give the relationship between the two table. So this is my second table along with the first table. So here I'm going to check. Okay, so the DOM is working in department 10 and SOM is also working in department 20 and another person is working in department 30. Again another DOM is also working in department 10. So like this I just given the relationship of the tables. So this is how we achieve the normalization or second normal form. It really necessary, we'll just make it as the established connection or established relationship between the table. So before the table was big, now the table are very simple and it will be multiplied. So like this you can use the second normal form. If the transitive functional dependencies is present, then we'll use the third normal form. If there is no transitive functional dependencies, means we'll just end with the second normal form. So, but we have to know about this third normal form also. So, what does a third normal form says? We'll look into that. Third normal form 3NF. Okay, so again it is also the same. So it also should be satisfied the below condition, and it should be follows. The table should be in the second normal form. Second normal form means again it have to be checked with the first normal form. Duplicate values, multi-value data, everything has to be checked, and partial functional dependency, everything has to be checked. Then it will be going with the transitive functional dependency. Transitive functional dependency, it should not be present. So then how to identify this transitive functional dependency? In the last session I have given the example. Again I'm going to take the same example. So see, this is the example I'm going to take over here. Okay, so this is my table: employee, employee name, salary of the employee, and commission of the employee. Salary 100, 200, 300, and commission. Not everybody earning this commission. Just give it as a random number. Okay, so this is my table. So here all the things are depending on the main attribute. Okay, so in this table now, as of now, this table we don't have any partial functional dependency, but what we have a transitive functional dependency. So indirect dependency will be there here, or few attributes are dependent on each other. So again, if the transitive functional dependency is there, again we have to separate the table like this. Okay, same. I'm going to select the reductions. Reduce 1. I just give it as a employee table. The reduce to, what it will be there? Reduce to, I'm just going as address table. Okay, so like this I'm going to select, and I'll keep the data as it is here. So no more duplicate present in the employee table, and one more table we need to create it. So which one is city table is created. I mean city, pin code, and country. So this is the separate table I am going to create. The table name is address table. I just create this. Okay, so I'll create the page like this, and first I use the pin code and I make it as my main key, primary key. So here all are interdependent. So among this I'm going to choose one attribute, my prime key attribute. then I'm changing the value over here. Okay, so here we can see some duplicate values are there, so that's why I am going to write this 101, and city is a US, and country is America, and it is a duplicate value, so that's why I just ignoring this, and I'm creating one more record, that is sorry, 102, that is by UK, and this is Russia. So this is how we use the another table. So if really necessary, we can merge it like this. So here I can select it. My pin code is foreign key. I just giving the established relationship of the table. Okay, so here you can write the person Jack actually is belongs to US and America, and person down is also belongs to US, America, and person Prince is belongs to the Russia. So this is a foreign key. I just make it as the relationship. So this is how we perform the third normal form. So this is about the third normal form. So this is how we achieve the normalization in industry. So I hope everybody really enjoyed this session. So if you really enjoyed, you can like and share and subscribe. Thank you. Bye bye. Signing off.